Our first speaker this morning probably needs little introduction, and indeed introduced himself on Monday in another session as one of the 4 riders of the apocalypse. Professor Daniel C. Dennett of the Philosophy Department at Tufts University in Boston is, as you know, one of the most eminent philosophers of his generation, and if I may say so, also one of the most readable and incisive, whether you agree with him or not. Educated at Harvard and Oxford, Professor Dennett has published prolifically and wide-rangingly, but particularly on philosophy of mind, books like Brainstorms, Consciousness Explained, and so on ethics, his book Elbow Room, and, of course, more recently on Darwinism, Darwin's Dangerous Idea, and on the negative implications, as he sees it, of Darwinism for religion, breaking the spell, religion as a natural phenomenon. Always clear, punchy, contentious, and controversial, I am sure Professor Dennett will not disappoint us this morning, and his title is Darwin and the Evolution of Why. Professor Dennett.
I simplified my title just a little bit. I think I know why I'm here. We had that wonderful talk by Jordan over the other day about imagery. And here is the picture that Matt Ridley was hoping to find. And here you get to see Tim White and David Kingsley being the fish on the ground. And of course, the amazing thing about this is that Matt Ridley was just standing around at the picnic, and he turned, and this is what he saw, and it was just a chance accident, you see, that this, I don't think you believe me, and you shouldn't, of course. The intelligent designer of this little tableau was Matt himself. The great thing about Darwin is the reason why we can take, in effect, all of human intellectual history and turn it and talk about the pre-Darwinian and the post-Darwinian worldview is easy enough to see. The pre-Darwinian worldview is what I call the trickle-down theory of creation. It takes a big, fancy, intelligent thing to make a lesser, but still marvelous thing. I think this idea may, in a certain sense, predate our species. Maybe Homo habilis, the tool maker, had some faint appreciation of the fact that it takes a big, fancy thing to make a lesser thing. You never see an axe making an axe maker. You never see a pot making a potter. It's always the other way around. And so it seemed just obvious to everybody until along came the bubble-up theory of creation, and that was Darwin's. And one of his early critics summed it up in a passage that is one of my favorites. In the theory with which we have to deal, absolute ignorance is the artificer, so that we may enunciate as the fundamental principle of the whole system that in order to make a perfect and beautiful machine, it is not requisite to know how to make it. The caps are in the original. This proposition will be found on careful examination to express in condensed form the essential purport of the theory and to express in a few words all Mr. Darwin's meaning, who, by a strange inversion of reasoning, seems to think absolute ignorance fully qualified to take the place of absolute wisdom in all the achievements of creative skill. Indeed, exactly right. He's got it. Yes, I'm amused. Some people laugh. They still don't realize, yes, that's the point. That is the point of Darwin's theory, and it is indeed a strange inversion of reasoning. A creationist pamphlet highlights just how obvious it seems that this can't be right. Do you know of any car that didn't have a maker? Yes, no. If you answered yes for any of the above, give details. Ha ha. Take that, you evolutionists. But the jocular incredulity of this page is a very telling point. This is a very counterintuitive idea that Darwin puts forward. It's very easy to understand the idea, but for many people, it is just impossible to accept. Now, here's another famous Brit, Alan Turing, and he had his own strange inversion of reasoning, and they're very similar. I want to draw attention to them. Hello. Here are some pictures of some pre-Turing computers. They're wearing dresses. They were called computers. That's what a computer was before Turing. In the old days, computers had to understand arithmetic. They had to appreciate the reasons for mathematical exercises that they engaged in. And Turing recognized that this was not necessary. So let's look at the comparison between Darwin's dangerous idea and Turing's. In order to be a perfect and beautiful computing machine, it is not requisite to know what arithmetic is. You put the two together, and what you get is the appreciation for the first time in the history of human thinking that there can be competence, magnificent competence, without comprehension. This flies in the face of what we tend to believe. We think, well, you have to teach people so that they understand things because their competence flows from their understanding. And in general, of course, that's true. That's why we have education. But it is not true everywhere. And what Darwin and Turing showed is that in the end, or in the beginning, it is competence without comprehension that creates competence with comprehension. Understanding, mind, consciousness, intention, is the effect, not the cause. Compare these two remarkably similar artifacts. On the left, a termite castle. On the right, Gaudi's La Sagrada Familia. They look so similar, and I want to say that they are profoundly different in the way they were put together, the way they were designed. They're both designed, and the way they were created. It is understanding the difference between the process that created the item on the left and the process that created the item on the right that we need to understand. It is the key. Now, here's a little sand castle that is made, beautiful little artifact. It is made by a single-celled creature, Amoeba, Difflugia coronata. This is a single eukaryotic cell that makes this beautiful little home for itself. Compare it with the sand castles that Homo sapiens makes. Same material, rather different shape, hugely different process of construction. Let's consider an intermediate case. This is a Caddis fly larva, and here's the sand castle that it makes. It's a food sieve. This is very cunningly designed. There are reasons for the location of the parts. This is brilliantly engineered. It bears a striking resemblance to another device for extracting food from water. Also brilliantly engineered, each part doing its role in its particular place. What's the difference between the two? There are reasons for the arrangement of the parts in both cases. In the caddis larva's food sieve and in the lobster trap. The difference is that in the caddis, the reasons are not represented anywhere. They are not represented in the caddis larva's little nervous system. They're not represented in the process that created the caddis fly's little nervous system. But they're the reasons that have been uncovered and tracked by the process of natural selection over the eons. I call these the free-floating rationales of evolution, and they are everywhere. There are reasons for the details of the shapes of proteins. There are reasons for the arrangements of parts within cells. There are reasons why the eagle's wing is the shape it is, and so forth, throughout the biosphere. Paley was right about that. There is design aplenty at every scale in the biosphere. It's just that until we came along, those reasons were not represented anywhere. One of my favorite examples is the cuckoo chick. As you know, the cuckoo is a brood parasite. They don't make their own nests. What happens is that when the cuckoo mother is ready to lay her eggs, she finds a host nest, waits till the hosts have laid their eggs and then flown away. Then she swoops down, lays her egg covertly, typically rolls one of the host eggs out. That's in case the hosts can count. There's a reason. The hosts come back and incubate the cuckoo along with their own. And when the cuckoo is born, typically before the other eggs are hatched, the first thing it does is try to roll the other eggs out of the nest, and it often succeeds. The reason for this is unmistakable. It is maximizing its own benefit from its hosts. But the little cuckoo doesn't understand that, doesn't have to understand that. This is competence without comprehension. Then along came us. Now, 10,000 years ago, this is a calculation that Paul MacCready, the late great green engineer, visionary engineer, made a few years ago. 10,000 years ago, if you took the human population plus their livestock and pets, this is shortly after the dawn of agriculture, you took all their pets, all their livestock, and then put them on this scale and weigh them against all the other animals on the planet. The terrestrial vertebrates, not the insects, not the worms, and not the fish in the sea. At that point, our ancestors plus their livestock represented, he calculates, less than 1% of the biomass by weight. What do you suppose it is today? Any guess? I hear 90, I hear 10. 22. 98%. We have engulfed the planet in 10,000 years. That is a biological phenomenon of stunning swiftness. No, doesn't have nothing. Oh, no, I'm leaving domesticated plants out of the picture altogether. Here's what he has to say about it. Over billions of years on a unique sphere, chance has painted a thin covering of life, complex, improbable, wonderful, and fragile. Suddenly, we humans have grown in population, technology, and intelligence to a position of terrible power. We now wield the paintbrush. And that's true. We do. And we do because we can. And we can because we comprehend. John Maynard Smith and Ernst Zothmary, in their wonderful book, The Major Transitions, list 5 major transitions. I'm going to concentrate on the last 2, language and human culture, because it's in our species, and it's only in our species that these transitions have occurred. They might occur in some other species. The difference is rather nicely revealed in this cartoon. It's the why, in particular, in the fellow's mind that makes the difference. Now, it is a truism that it's human culture, technology, intelligence, that has produced this 10,000-year explosion, the MacCready explosion. And the traditional model of this has got this one problem. Who invented words? Who invented arithmetic? Who invented music? Who invented maps? And the answer is nobody. Who invented money? Nobody invented these things. Well, but then how did they get to be such perfect tools for the jobs that they do? And the answer, of course, is that they evolved. They evolved. They evolved just the way animals and plants and viruses do. They evolved by natural selection. That's the only way that such excellent designs could get accomplished in this world. What I'm talking about, of course, is what Richard Dawkins calls memes. Memes are analogous to genes. They are the replicable items in the cultural sphere, or to viruses. Well, what's a virus? A virus is just some nucleic acid with attitude. It's not alive, but it surely does replicate, and it surely is subject to evolution. A meme is a data structure with attitude. It's made of information, and it has, like a virus, it has the wonderful property, and it doesn't have to have any comprehension to do this. It has the wonderful property of provoking its own replication when it gets in human heads. Now, we're all familiar with the tree of life, with phylogenetic trees. Interestingly, before there were phylogenetic trees, there were glossogenetic trees worked out by great scholars of language, the history of language. And here are some current, here's the Proto-Indo-European languages, the Finno-Ugric languages, the languages of China, the Proto-Mayan languages. All of these languages have clear, there are glossogenetic trees that trace back their ancestry. Now, there's a problem with them, and it's remarkably similar to the problem with the tree of life in general. And that is, just as there's horizontal gene transfer, which messes up the tree of life in the early eons of life on this planet, so there's tremendous horizontal word transfer. All the words in English that come from French, for instance, even though French and English split off many hundreds and hundreds of years ago, thousands actually, on the Proto-Indo-European language tree. It's rife in language, so it's words that are more trackable items in whole languages. But words have ancestries too, and words are memes that can be pronounced. Richard Dawkins the other day spoke about the fifth bridge, and that was what he called digital Darwin, the digitization of evolution as we understand it. And I want to point out that language is also digitized in exactly the same sense. What do you see? The cat. But notice that the H and the A are exactly the same shape. And yet, automatically, without comprehension, without needing comprehension, you change the H and the A and turn it into the cat. This is correction to a norm. This is the essence of digitization. It's where you get high-quality replication. Now, that was written language, but it's even more dramatic, I suppose, in spoken language. So a little exercise. I want you to listen very carefully and then repeat after me. Are you ready? Here we go. Mundify the epigastrium. Again. Once more. All right. Do you know what it means? No. Don't need to. You don't even have to know if it means anything. All right. Here's example 2. Are you ready? All right. Now do it again. You can't do it, can you? And it's not because of a problem with your ears or because I spoke softly or anything like that. It's that you didn't have the set of norms of pronunciation, phonemes, that automatically fixed everything and made it into a memorable, indeed almost unforgettable little pattern in your head. That is digitization, and without it, language would not have the tremendous power it has. That's why, although chimpanzees have some cultural transmission, it never builds. It can't ramify the way human culture can, because although a chimp can copy another chimp with a termite fishing stick or something like this, basically, for that chimp, it's all, they can't they can't articulate it and digitize it, and that's why only one species has culture really gone viral. There are norms of correction. Here's a completely different example. Information about kayaks is stored in Inuit brains, but also in their kayaks, only on the defaulted presumption that the design is good, even if it isn't understood. This is a kind of digitization. And thank you, Peter Godfrey Smith, for drawing attention to a beautiful quote, not about Inuit kayaks, but about Polynesian war canoes. Every boat is copied from another boat. It is the sea herself who fashions the boats, choosing those which function and destroying the others. This is evolution by natural selection without genes. Memes are like software viruses. In fact, I want to say they are software viruses. But to understand this, you need to adjust your imagination about both computation and software, and I don't have the time to massage your imagination about that today. So I'm just going to go on and compare the prevailing wisdom, where culture is seen as composed of good things that are invented by innovators with insight, recognized and valued as such by adopters, with this is a sort of an economic model of possessions. We save the good stuff, pass it on, protect it, and so forth. And indeed, a lot of culture is of that form. But the Darwinian memetic model is much more general. Culture is composed of good, bad, and indifferent things, created by processes with variable insight, sometimes a lot, sometimes none at all, adopted with variable recognition of value. Sometimes people don't even realize they're adopting anything. Having an economic model then just is a limiting case. The traditional model is not ruled out, it is simply a limiting case in the spectrum of possibilities. So if we look at them together, side by side, we see that the traditional model says culture consists of good things, treasures. Darwinian model says, well, good, bad, and indifferent. They're invented with insight, you know, Shakespeare and Einstein and all those other great heroes of culture. Darwin says, no, there's sometimes a lot of insight, most of the time not. They're valued according to the traditional law. Well, sometimes they're even disvalued, but they're just pernicious. They are truly viral, and you can't get rid of them. They're passed on in both cases with improvements on the sort of traditional progressive view of culture. The Darwinian view is, well, with mutations, some of them good, some of them bad. So the economic model of the traditional view is simply a limiting case in the Darwinian view. Darwin begins the origin with a wonderful pedagogical device. He describes what he calls methodical selection, animal and plant breeding. Then he goes on to unconscious selection, where the domesticators don't know what they're doing, but their behavior has a direct influence on the trends that happen. And then he gets rid of mind altogether and says, and then there's natural selection. Of course, in our own day, we've added a fourth, genetic engineering. It's another way in which designs change thanks to human intervention. Now, let's put them in the right order temporally. First, there was natural selection, then there was unconscious selection, then methodical selection, and now genetic engineering. The same thing is true in meme land. There are memes that were naturally selected. We might think of them as synanthropic. They're like pigeons and squirrels and barn swallows. They're wild, but they are evolved by natural selection, unguided by human interference, to thrive in human company. There's unconscious selection, like the differential replication of tunes, what the Germans call earworms, those tunes you can't get out of your head. There's the methodical selection of domesticated memes, like calculus, which is not particularly catchy. It's a meme, but it only reproduces with a lot of hard effort on the part of its stewards. And we add memetic engineering, otherwise known as spin doctoring, advertising, propaganda, etc. Once we have our cultural software installed, this changes the process of creation that is possible on this planet. And it permits us, for the first time, a certain sort of top-down patterns of causation, where the reasons can have an effect on the design directly. I think one of the people who has been most articulate and imaginative on this is my friend and colleague Doug Hofstadter in his book, I Am a Strange Loop. Our minds can be dominated or driven by an idea or by ideas. This is what has happened for the first time with us. And this is the fulcrum of intelligent design. Back to our original slide. There are reasons why every little bit of mud is where it is in the case of the termite hill. But in the case of the Gaudi creation, he represented those reasons. He thought it out, and he directed from the top down. The workers were given directions by an intelligent designer, which is exactly not what happened in the case of the termites. Amazingly, wonderfully, one of my favorite examples of top-down design is Turing's computer. He had the whole vision of that computer before it was ever built. It was because he had worked it out in his head that there was ever initiated the process to make the actual artifact. We are the first intelligent designers in the tree of life. Our natural tendency to interpret all design is top-down. Remember, that's the pre-Darwinian worldview. That natural tendency, as being representation-driven, is both anachronistic and anthropocentric. A certain text says in the beginning was the Word. No, no. Words are a very recent invention. One of the most recent products of blind, purposeless, absolutely ignorant natural selection. There is no work for an intelligent artificer God to do. Well, you want to retreat then to a deist God? Well, you can. I agree with those who say there is no logical argument proving there isn't a deist God. So retreat to a deist God if you must, but it is, in a word, lame. When I dress up, I usually have this little Darwin pin on my lapel. And one time I was at a meeting, and Murray Gell-Mann, the physicist who knows everything, spotted it. And he said, "Oh, Dan, that's very nice. I like your Darwin pin. You know that the original Christian fish symbol is the first acronym. It's ichthus, the word for fish. That's why they use the fish. Well, what does ichthus stand for? It stands for Jesus Christos Theo Ios Soter, Jesus Christ, God's Son and Savior." Interesting. I said, "Yeah, that's wonderful, Murray." He says, "What I want to know is, what does DARWIN stand for?" Well, I'm not a classical scholar, but I did have some high school Latin. So I said, "Give me a cup of coffee, and I'll come back to you in a half an hour, and I'll tell you what it stands for." And I worked out something which I'm actually pretty proud of, and here it is. Now, it's in Latin. Now, there's no W in Latin, so you have to use W. So what does DARWIN stand for? It stands for, I'll give you the Latin first so that the classical scholars here can figure it out for themselves. Delere auctorem rerum. Hello. Ut universum infinitum noscas. Destroy the author of things in order to understand the infinite universe. Thank you for your attention.